refined engineering design, and the advances in conventional technology available in her day. But it took the singular genius of one man to pull this all together. And you really can't understand one without understanding the other. So this evening, we're going to examine the legacy of William Francis Gibbs and his big ship. Gibbs was born in 1886 in Philadelphia to an immensely rich family. And when he was 8, his father took young Willie and his younger brother Frederick to the cramped shipyard in Philadelphia to witness the launching of the St. Louis. From that day forward, Willie dedicated his life to ships, and as he later said, he never regretted it. He would spend his boyhood studying technical manuals in preparation for his life school. He enrolled in Harvard in 1906, ostensibly to study engineering, but his inability to master simple arithmetic did not bode well for his academics. He left after 3 years, some say because of his father's financial collapse, and he eventually took a law degree from Columbia with the agreement that he would practice real estate law for a year to help with family finances, after which he would be able to pursue his dream. But while in his law purgatory, he continued to study engineering out of books. William Francis, with some assistance from his brother Frederick, would design and redesign different iterations of their great 1,000-foot ocean liner that would be the largest built and the fastest built. He was able, by determination and sheer force of will, by 1916, to attract the attention of General Electric CEO William Emmett and Admiral David Taylor. Admiral Taylor was probably the preeminent naval architect of the day, and he saw the work of inspired amateurs behind the design of these ships. And he offered to take their hull design to the U.S. Naval Experimental Model Basin to test it. He took William Francis under his wing and became his informal mentor. The great German passenger liner Vaterland was quarantined in Hoboken at the outbreak of World War I and converted to the troop ship Leviathan. After the war, the U.S. Shipping Board wanted to reconvert her to passenger service once again. Gibbs won the contract, and thus was born the firm of Gibbs Brothers Incorporated. They approached Blohm and Voss, the original builders of the Vaterland, for their contract and construction drawings. Blohm and Voss wanted $1 million, and this was in 1921. William Francis said no thanks, although given his penchant for sailors' vernacular, I imagine his response would be more solid. So the firm undertook the gargantuan task of measuring every square inch of the ship in order to come up with their own construction blueprints that would serve as a baseline for a conversion back into service. And the result was a magnificent ship that gave the U.S. Merchant Marine one of the largest and fastest liners on the Atlantic at the time. With its reputation ascending, the Matson line approached Gibbs Brothers and commissioned them to design his first ship built from scratch, the Malala. It was a Hawaiian run, and hence the difficult name to pronounce. In any event, on her trials in 1927, she was hit broadside by a Norwegian freighter. Now, Gibbs had always been haunted by the tragedy of the Empress of Ireland, which also had been hit broadside by a Norwegian freighter in the St. Lawrence Seaway. She sank rapidly with the loss of over 1,000 lives. However, lesson learned, by virtue of his design and compartmentalization, along with the addition of automatic watertight doors, while severely damaged, the Malala survived. she was towed back to the shipyard, repaired, and would go on to have a very long and successful career. His reputation for safety was cemented, and his next big commission was for a quartet of ships by the Grace Line, one of which is the Santa Rosa shown here. And you'll begin to see a profile start to emerge that would evolve over the years. They were outfitted with compact and efficient American-built turbines. They could operate at high pressure and were better in performance than the turboelectric machinery in vogue at the time. That caught the attention of the U.S. Navy, who wanted to upgrade their aging fleet. Gibbs won the contract to design a new class of destroyers, the Mahan class. With the aging Leviathan taken out of service, Gibbs was again approached for a commission to design a medium-sized replacement. And this is the America. And you can see, again, the refinement of that profile. And in many respects, she was sort of a smaller version of what would become the United States. And Gibbs thought that this would be just a short stepping stone to his 1,000-foot ocean liner. But history had other ideas. Based on his work with the Navy, both the British Admiralty and the U.S. Navy approached Gibbs to build wartime cargo ships that could be constructed faster than the German Navy could sink them. Hence, hundreds and hundreds of so-called Liberty ships were produced using pioneering techniques such as all-steel welded hulls, prefabricated modules that really kind of allowed for an assembly line kind of production, standardized parts which could be manufactured anywhere in the United States and shipped to any shipyard in the United States. And for all this work, he made the cover of Time magazine in September of 1942 in recognition of his contribution to the war effort. With the war over, he could finally turn his attention back to designing his big ship. And his firm, now Gibbs & Cox, was put to full task for that. With a combination of cajoling, politicking, and obstreperousness, he did finally get his wish, was awarded the contract, and the ship would be built with a large government subsidy. As part of that agreement, she would be built to U.S. naval specifications for conversion to a troop ship within 48 hours, if necessary. So on May 3rd, 1949, with the U.S. line as owner and the Newport News Shipbuilding and Dry Dock Company as constructor, the contract was signed, and there's William Francis at the opposite end of the table with his head resting in his hand. Newport News was a very reputable firm. Its motto was, "We shall build good ships here, at a profit if we can, at a loss if we must, but always good ships." The United States Line had originally wanted a 2-class ship, but Gibbs insisted on 3, and as one Gibbs & Cox employee said, "You do not argue with God." So he finally had his dream in hand to build a large, fast ocean liner. Preliminary subsections of the ship were actually started to be constructed off-site in 1949. But February 5th or February 8th, 1950 saw the actual official keel laying in shipway number 10 grading dock, and she was assigned hull number 488. The hull would be all welded, which was the first time that such a large ocean liner was going to have a welded steel hull. Up to now, it had been riveted. But part of the advantage was that she had a much more hydrodynamic skin, which decreased resistance in the water. She was also built in dry dock, the first time this really had been done, but it is now the norm for all large ships being built. here you can see some of her inner floor sub-assemblies awaiting installation in the grading process. With the keel laid, the plating progressed, and she began to rise and take form and shape. By October of 1950, the prefabricated bow section was being lifted into place. This is the great French liner Normandy, and Gibbs had studied her extensively. She had a revolutionary hull design when she was built in 1935, with a flared hull and a prominent bulb and a clipper bow. All of this contributed to her remarkable hydrodynamic resiliency and lack of resistance as she went through the water. However, Gibbs opted for a more conventional raked bow with a much more modest bulk because the model test had convinced him that it was better for speed and stability. And by the way, these construction pictures, especially of the underwater shape, were classified for years under the guise of national security because she had been built to naval specifications. I think it was more of a pretense that Gibbs didn't want anybody knowing what was going on, so they couldn't reverse engineer a ship the way he had done many times. As building progressed, he'd make frequent trips to the shipyard, sneaking up on supervisors, foremen, welders, all to make sure that everything was being done exactly as he wanted. By June of 1951, the superstructure was in place. Now, in order to build a fast ship, and he wanted the fastest, he had to fit maximum propulsion into the lightest displacement hull. So one of the ways he achieved that was to use aluminum for the superstructure. That, and again, this was the first time that aluminum had been used to such an extent on a passenger liner. A couple problems with aluminum, though, is that it had to be insulated where it came into contact with the steel hull to prevent galvanic corrosion. And at the time, aluminum could not be welded. It had to be riveted, but it was a very, very specialized task to rivet aluminum. This is her 65-foot high forward funnel. And you'll notice here these sampan fins. They were designed to deflect smoke away from the decks. Originally, they were angled down, but wind tunnel tests showed that too much smoke still flowed onto the deck. And a shipyard apprentice suggested if you oriented them horizontally parallel to the deck, it might work better. So wind tunnel tests were conducted, and when it was shown that in fact they did perform better, Gibbs just grunted and walked away without comment. The apprentice, Howard Lee, says that he was never thanked or even acknowledged for his suggestion. And as you can see, it was incorporated in the final design. But then William Francis Gibbs did not take being bested lightly. This is the installation of the rudder, which is probably one of the most tedious tasks in building a ship because the overhang at the stern prevents the use of a crane. So you have sky hooks permanently welded to the hull, hoists and chains, and brute force to put it into place. Ships designed for high speed are notoriously subject to vibration due to many factors. Two most prominent ones are the immense force that the propellers exert on the water, and also a phenomenon known as cavitation, which essentially is the formation and collapse of tiny bubbles due to differential pressure by the spinning screws. They not only contribute to vibration, but they also have a corrosive effect that can actually physically eat through the blades of the propellers. As you can see here, her inboard propellers have 5 blades, with the outboard propellers having 4 blades. And this was a design conundrum that was being refined even as the ship was built. Now, Gibbs was notoriously uncomfortable around women, but he entrusted the solution of this problem to Elaine Kaplan, who was a brilliant mathematician and engineer. He was also notorious for hiring on merit, regardless of race, religion, gender. If you had the skills, you were on his team.